So now we get to do the same thing, except our polynomials have a non-zero number in front, or a non-integral number. It's not 1. So how does that change? State the zeros of the polynomial function. Well, I've got my factors written in. My zeros would be 2/3 and 8/5. How is the constant term in the polynomial and the constant term related in the factors? Well, those numbers multiply to each other. The -2 and the -8 actually multiply for 16. So -2 times -8 is equal to my +16. Well, what about the coefficients, 3x and 5x? Well, those guys multiply to my 15x. And that's something that's going to take effect for when we're predicting what our possible roots or zeros are. Not much really changes. The factors have relationships to the original polynomial, but what we have to worry about is that non-zero factor, or the non-1 factor. And that makes my zeros into fraction forms themselves. Generally, it's referred to as P over Q. I need factors, or potential factors, of the constant divide by potential factors of the leading coefficient. My 2 and my 8 were clear factors of my constant term. And my 3 and my 5 are related to factors of my leading coefficient. So that's always going to be the case. And we'll see that in 2 examples today. So just a quick look at one more where the numbers are a little bit bizarre. The zeros of the polynomial based on the factors: 3 over 2, 7 over 5, and -11. When I take a look at multiplying those zeros together, -3 times -7 times 11 generates my positive 231. The constant factors, the 2, the 5, and the x, those leading terms, if I multiply those together, I actually generate the leading coefficient, 10, 2 times 5 times 1. And when we're looking for potential zeros, we've got to follow this observed pattern. I need to look for factors of the constant term divide by factors of the leading term. It's generally referred to as a P over Q relationship. Let's turn the page over and try to. So someone worked through all of the factors of 9 and all of the factors of 5 and found all the potential P divided by Q numbers, and they've listed them. I've got a whole list of potential zeros. So use the potential zeros to list binomial factors. I'm going to start off with writing and then finish writing. It's x plus 1, x minus 1, x plus 3, x minus 3, and I'll continue. So you get quite a list going through the pluses and the minuses. And then I have to complete the division, and I'm going to show it using as much algebra as I can. So show that x equals 1 is a 0. So by plugging 1 into my x's, I actually have positive 60 and negative 60, so that's 0. So that means x minus 1 is a factor, and x equals 1 is a root, which I'm now going to long divide. So I did my synthetic division and then took a look at my resulting trinomial and could actually factor my resulting trinomial a little bit. I had to find 2 numbers that multiplied to positive 45 but added to negative 46. So they had to times to 45 and add to negative 46. Those two numbers are negative 45 and negative 1. I substituted those in for 46 and then factored in pairs to generate a final answer that is x minus 1 times 5x minus 1 times x minus 9. So now I can say the solution, the equation, can be solved with x equals 1 or 1/5 or 9. Those are my possible solutions. And there's one more example to try out. Here we haven't been really given any clues, so we have to go through all the steps. My potential zeros. So my potential zeros are plus and minus 1, plus and minus 1, plus and minus 3, plus and minus 1 over 2, plus and minus 3 over 2. And now I'm going to use my calculator to help me figure out which one is which. Let me tell you what I've done. I plugged in equation into my y equals. So I made that into 1. And then I set my table set to ask. So my table set is set to ask. And then I can enter all of those potential roots or zeros or x-intercepts. And it turns out that the most confusing one is the one that actually works. So when I look at my table, I found out that when I plugged in 3 over 2 or 1.5, that I actually got a 0. So when x is 3 over 2, y is 0, which means 3 over 2 is a root, and I'm going to have to do some synthetic division, and I would imagine some quadratic formula after that. You could also have found your potential x-intercepts by graphing. So you could have taken a look at that and looked at your x-intercepts. But I tried to do it the legal method. So synthetic division is what I'm setting up next. So the synthetic division was fun. I generated a whole bunch of 2's. The quotient is 2x squared plus 2x plus 2. I factored a 2 out and applied that 2 to my initial divisor so that I have whole numbers instead of fractions. 6 of one, half dozen of the other. Depends on how the answer is phrased, I guess. And now I have to complete factoring by using the quadratic formula. So I'm going to write that out below. Let me move her down. So as you may have guessed, the quadratic formula generated the square root of a negative number. The discriminant was negative, which means it's actually not possible to break down x squared plus x plus 2 into other factors, which means I'm done. There was only one solution to this equation, and that was x equals 3 over 2. Let's try out this work. Thank you very much.